Well, welcome back, good friends. As we move into Module 4, we will move beyond confidence intervals and begin to think about hypothesis testing. I want to lay a little foundation work, and then I will show you how to conduct a hypothesis test. Remember this diagram. We've used it a lot. Descriptive statistics describe, inferential statistics infer. When we're doing hypothesis testing, we're using some descriptions to infer. Most of the time with the population, we do not know the mean, we do not know the standard deviation, the variance, or even the number in the population. What we do is we take a sample. From the sample, we calculate X bar, the mean of the sample, the standard deviation, the variance we can use, and then the number in the sample. We will know these amounts, and we can use those amounts to infer things about the population mean. If we take a sample and predict using X and S, we need to know some things that are traps. We'll talk about confidence. We'll talk about using S to predict sigma. But given an X bar and an S, we can establish a confidence interval for mu. And if we can establish a confidence interval for mu, then we can test a claim about the value of mu. The central limit theorem allows us to use X bar, S, and N to establish that confidence interval. If you will recall, the central limit theorem gives us a lower bounds and an upper bounds for mu at a given level of confidence. Not very difficult to handle. Again, the central limit theorem says that the mean of the sample is normally distributed around mu with a standard deviation of X of S bar equal to S over the square root of N. What happens is the larger the sample gets, the more tightly X bar clusters on mu. Now, if X bar clusters on mu, then if we take X bar, mu should cluster on X bar. X bar can be used to predict mu, and larger samples make S a more accurate predictor of sigma. In descriptive statistics, we build a confidence interval which can be established around a known mu for where our X bar will occur. In inferential statistics, we kind of reverse that. We don't know mu, so we take X bar and we use it to predict mu with a given level of confidence. And how do we use the central limit theorem to help us draw meanings about populations? Well, what if a manufacturer makes a claim about a product? Could we take a sample and test the claim? Yes, this is known as hypothesis testing. The central limit theorem is the foundation of all hypothesis testing. Again, the central limit theorem says that if we take infinite samples of size n, then the X bars, the means of the samples, are normally distributed around mu with a standard deviation of their distribution equal to S divided by the square root of N. That's what we do. You're making headway. You keep climbing up the rungs. You will soon reach the top. Now, the good thing is, once we get through hypothesis testing, we will begin to use SPSS and statistical software to help us see how to do these things, and you become more of an expert, which I think you will enjoy that.